This is Module 7, Investigation 9, Negative Angle Measures, coterminal angles, and the periodicity, okay? So consider the box on the end of the fan blades from the Investigation 2. If we reverse the polarity in the fan motor, the blades will be set up to move the clockwise direction. So when we think about the negative angle, which is it going to this direction, so clockwise. So that's the what we're gonna think about right now, okay? So let's start from number 2. We're gonna fill in the table of the value, which is t equal to 0, negative pi over 2. So which is, if you think about this, so this is you can think about a 0, but now you have a clockwise. So instead of the 3 pi over 2, we got negative pi over 2 here. And then this is going to be a negative pi, and this becomes negative 3 pi over 2, which is actually the same as, this is pi over 2 positive, and this is the same as pi, and this is the same as 3 pi over 2. And then this becomes actually, if you go around, it's going to be negative 2 pi, but also same as the positive 2 pi 2, okay? So so the red means that you go in this direction, the counterclockwise, and then the negative means clockwise. Okay, so we plug it in. So in number 2, cosine t, but t is a 0, negative pi over 6, so on. Okay, so if you do that, and then this is kind of special angles with pi over 6. So if I draw some right triangle in the first quadrant, okay, so let's say this is a pi over 6. And then the ratio is always 1, 2, and the red 3. And then if you have pi over 4, which is pi over 4, the ratio is 1, 1, red 2. That's a ratio, basic ratio. And then if you have pi over 3, which is ratio is a 1, 2, red 3. Okay. And then we can just change the sign, the angle as in quadrant, okay? So the sine of cosine of 0 is actually the 1. And then negative pi over 6 is the cosine is a negative pi over 6 is a quadrant 2. And quadrant 4 actually. So the x is always positive. So it stays a positive. So you can just say positive x. Because the cosine, okay, cosine is always x over r, isn't it? So as long as x is a positive, stays a positive. X is a negative, stays a negative. So negative pi over 6, which is in the quadrant 4, always x is a positive. So x from this triangle, right? So x is a red 3, and the odd is over 2, right? Okay. And then negative pi over 4, which is 1 over red 2, still in the quadrant 4, okay? Which is, if you rationalize it, same as a red 2 over 2. Negative pi over 3 is still in the quadrant 4. So it becomes 1 over 2. And then negative pi over 2 is exactly on the vertical axis, which is going to be negative 1, which is cosine with a negative, it's going to be a 0. And then the negative 2 pi over 3, which is in the quadrant 3 right now. Quadrant 3, x is a negative. So now it's the same as pi over 3. So pi over 3, we have a 1/2, but it becomes a negative 1/2. And then the negative 3 pi over 4 is same as a pi over 4, but it's a negative. So negative red 2 over 2. And then negative 5 pi over 6 in the quadrant 3 too. So it's all quadrant 3. So x is a negative, so you find the pi over 6, which is negative red 3 over 2. And then negative pi, which is the same as a pi, which is going to be a negative 1. Now, when you have a negative t means a cosine negative 0 is a 0 anyways, is 1. But it becomes a negative of the negative pi over 6 becomes a positive pi over 6. So cosine pi over 6 is quadrant 1 is a positive, so red 3 over 2. And then also become quadrant 1, which is red 2 over 2. Positive 1/2. And then 0. And then now, when you put 2 pi over 3 is a positive, is a quadrant 2, but quadrant 2 and 3 is an x is a negative. So you say it's a negative 1/2, negative red 2 over 2, negative red 3 over 2, and it's going to be negative 1. So what you notice is cosine negative t, it's the same as a cosine t. Now, for the sine functions, okay, so sine t, sine of the 0 is a 0. But sine of the negative pi over 6, but the negative pi over 6 is in quadrant 4, right? So quadrant 4, sine is always negative. So pi over 6 is sine t is the y over r, right? So y is 1 over 2, which is a negative 1 over 2. And then negative pi over 4, 1 negative red 2 over 2, because negative 1 over red 2, right? And then it's going to be negative red 3 over 2. And then it's going to be negative 1. And then negative 2 pi over 3, which is quadrant 3. Sine still stays the negative, right? So it's same as a negative pi over 3, which is negative red 3 over 2. And then the negative 3 pi over 4 quadrant 3, which is still stays a negative red 2 over 2. And then it just stays a negative 1/2, and then it becomes 0 again. But when you put in the 0, which is sine is a 0, right? But negative pi over 6 become positive pi over 6. The sine is in the first quadrant is always positive. So positive 1/2, positive red 2 over 2, positive red 3 over 2. And then negative become positive, pi over 2 is 1. And then 2 pi over 3 now becomes quadrant 2, which is sine is a positive. So everything just stays a positive. So get the same values. Okay, and then 0 here. So what you notice that is sine t and sine of negative t is always what signs are changing except the place of the 0, right? So if I say sine of negative t, if you want to make it equal to, you need to multiply negative 1 to the sine of t. So that one we call the odd functions. And this one we call the even functions. Alright, and then let me try the number 9. So in number 9, here, right here. Determine the value of the x, 0, x is between the 0 to 2 pi, such as a cosine x is a red 3. So we are looking for the angle this time, okay? So cosine is a positive in the quadrant 1 and 4, right? And then the ratio, the horizontal axis is going to be the red 3 over 2, isn't it? Right, which is, this is, yeah. So we are looking for the two angles. This is kind of special, isn't it? So I already showed you that what it is, right? That was, so the data for here should be the pi over 6. So in the pi over 6, and also you have angles in the quadrant 4, isn't it? So in order to find the quadrant 4, you always subtract 2 pi of the pi over 6, and then becomes 11 pi over 6. So that's the two angles you can find in the quadrant 1, and then in quadrant 4, sorry. And then B, write the list of all the value x as a cosine that is, okay? So I said this we call the coterminal angles, okay? So you come back to every 2 pi, right? So you can just say one angle is a pi over 6 in the one revolution, and the second revolution you can get the 2 pi n. And also another angle you can get it from the 11 pi over 6, and then every 2 pi n, but n is integers. Okay. Alrighty, that's all for the answer for this one. Okay, so this is, you can actually put out all the angle possibly created. Alright, thank you for listening.